Motor graders play a vital role in the Municipality of Anchorage's snow management plan. With the city accumulating over 100 inches of snowfall annually, these machines are crucial in keeping our network of roads and sidewalks open and safe. However, like many tools, these machines are only as helpful as the operators who run them. So let's take a closer look at how we, as operators, can ensure their safe and effective use while maintaining Anchorage's roadways. When first approaching your grader, it should look similar to this. The blade implement is grounded, the rear left panel is open, and the master switch is turned off. Since we perform a full 360 inspection before each use, it is best to start with the left engine compartment. Here you will find a dipstick for the engine oil, as well as one for the transmission oil. The engine oil should be checked prior to starting the machine, whereas the transmission oil will be checked later, once the machine is running. While inside the engine compartment, we will also need to give it a thorough inspection, ensuring there are no signs of leaks. Behind the engine compartment is the rear panel. This area houses a sight glass for the hydraulic oil level, as well as the master switch. This switch, or battery disconnect, helps to prevent the batteries from losing charge while the grader is turned off. Our fleet utilizes a blue hydraulic oil. This helps to identify it from other fluids should a leak occur. Ensure that the hydraulic oil can be seen within the sight glass before each use. Below the rear panel, you'll find a switch with a red safety cover. This is the emergency shutdown switch and can be used to shut down the engine during an emergency. Stepping back, we will need to inspect the tires for damage. Things to look for include cuts, gouges, missing tread, and uneven wear. Similarly, it is important to be aware of the brake lines behind the tires. These brake lines can become damaged by loose tire chains slapping against the machine. Because of this, we must always confirm that the brake lines are intact and that no leaks are present. As we wrap around the backside of the machine, we'll find an assortment of safety equipment. This includes a rear backup camera, cautionary signage, as well as several lights. All of these pieces should be wiped clean in order to provide maximum visibility. Additionally, it is important to note that there is a latch on the left rear corner of the machine. This latch allows the fan housing to swing open. Therefore, it is important to verify that the latch is securely closed in order to prevent unwanted movement and possible damage. Lastly, you will need to ensure that your rear light brackets are secured in the upright position. Making our way to the right side of the machine, we'll find another rear panel. This one houses the batteries, as well as the engine coolant reservoir. The red coolant used should be visible within the reservoir. In front of the right rear panel is another engine compartment. Open it and inspect the area for leaks. Just like the other side, we will need to inspect these tires, along with their brake lines, for damage. Next, we come to the cab. Starting from the top, you'll notice several work lights. Typically, you will have a set facing backwards, a set facing right, and another set facing forward, in addition to your strobes. These lights can become damaged by low-hanging tree branches, so it is important to check that they are not dangling and that they are facing their intended direction. Looking down, we have our windows. Inspect the windows for cleanliness, as well as any chips or cracks. If the windows are dirty, take a few minutes to clean them so as to give yourself the best possible visibility. With the windows, we also need to inspect our wipers. Ensure their rubbers are in place and that the washer fluid hoses are secured. Below our windows, we have a set of lower work lights. These lights are intended to illuminate the blade's work area, so we'll need to ensure that the lenses are clear of dirt and grime. Next, we have our right side ladder. This provides access to the cab via the right door. This ladder can become damaged by the gate being tucked in too close to the machine. Inspect the ladder for bent or cracked rungs, as well as excessive wear along the side rails. Moving forward, we're ready to look at the implement as well as the blade's work area. Starting from the bottom of the mold board, we have our cutting edge, as well as our wear plates. The cutting edge must be replaced when there is less than an inch remaining, or about 2 fingers. The wear plates help to reduce wear to the side of the moldboard, especially when up against concrete curbs and gutters. The cutting edge, as well as the wear plates, should be checked periodically throughout the shift. Keep an eye out for loose bolts and missing nuts. Above the cutting edge bolts is the side shift cylinder. This cylinder allows the moldboard to be shifted laterally during operation. The side shift cylinder connects to the moldboard at all four corners of the side shift cylinder. 2 on the left, as well as 2 on the right, both top and bottom. Each corner's connection point houses a set of slide shims that enables the moldboard to slide freely. These shims are located behind the moldboard and need to be inspected daily to ensure that they are not overly sloppy. A little bit of play is normal. Along the bottom of the side shift cylinder, you'll find the moldboard pivot pins. On older models, these will have castle nuts. The moldboard pivot pins are what connect the side shift cylinder to the circle. At the top of the side shift cylinder, we have the cut angle adjustment cylinder. Similar to the moldboard pivot pins, the cut angle adjustment cylinder also connects the side shift cylinder with the circle. The cut angle adjustment cylinder allows the blade to be pitched forward or back. All of the pins underneath the circle should be inspected for adequate lubrication wherever a grease zerd is found. Similarly, make sure to check each of the cylinders for leaks. At the end of the moldboard is the gate. These gates are custom, semi-permanent additions to the machine. The gate itself is removable, but the bracket and cylinder remain on the machine at all times. The gate connects to the grater via 4 large pins, 3 for the bracket, as well as 1 for the top of the cylinder. Each large pin contains a hole that houses a smaller keeper pin. You must always ensure that these pins, as well as their keepers, are in place. It is crucial that the top pin is inserted from the front so that it cannot be pushed out by built-up snow when plowing. Similar to the moldboard, the gate has its own cutting edge. The gate's cutting edge is a wear item that will need to be changed over time. Keep an eye on the gate's cutting edge and ensure that it's wearing evenly, while also watching the cutting edge bolts, as these will grind down when up against concrete curbs and gutters. Along the top of the moldboard, you will find 2 hydraulic hoses. These hoses connect to the gate cylinder and run the length of the moldboard. This area collects a lot of dirt and ice, so it is important to clean it off when doing your inspection. Above the moldboard is the circle, or turntable, and above that is the drawbar. Looking underneath the turntable, you will find several cast blocks, each with 3 vertical bolts. Each cast block houses a wear plate that will naturally degrade over time, eventually causing excess movement within the circle. Thus, it is important to verify that the bolts in each of these cast blocks are tightly secured. Moving to the outside of the circle, you'll find that the circle and drawbar are separated by a thin set of shims that aid in the turntable's rotation. These circle shims are placed around the full circumference of the turntable, and it should be noted that they too can become loose over time. Looking from above, you'll find several plates mounted to the top of the circle, each with 2 vertical bolts. These plates are what hold the circle shims in place and provide a good visual indicator as to the location of each circle shim. Moving up slightly, we have our drawbar. The drawbar is the triangular frame welded to the top of the circle. On the rear of the drawbar, you'll find a diagonal cylinder that connects the back of the drawbar to the saddle above. This is our drawbar shift cylinder, and it allows us to sway the drawbar left or right. Each end of the drawbar shift cylinder is connected via a ball and cup joint. These joints require a generous amount of lubrication due to their high amount of wearable surface area. Also, it is important to note that the cups often sport a set of shims. These shims can be added or removed in order to limit the excess movement within each joint. Nearby on the drawbar, you'll notice 2 tall vertical cylinders, also with ball and cup joints. These are the lift cylinders and are responsible for moving the blade vertically. Each lift cylinder controls one side of the moldboard. There's one for the left and another for the right. These vertical lift cylinders connect the drawbar to the saddle. All of these cylinders should be inspected for leaks as well as proper lubrication. Above the drawbar is the saddle. The saddle contains a series of holes as well as a hydraulic pin. The The hydraulic pin is located on the back side of the saddle, and when removed allows the saddle to be rotated left or right, further increasing the range of motion of the drawbar. This function can be useful in scenarios where the scope of work is beyond the physical reach of the blade. It is extremely important that the hydraulic pin is fully seated in its desired hole when adjustment is necessary. Typically, and in most cases, the hydraulic pin will be locked into the center hole. Moving forward, we have another set of work lights mounted to the upper frame of the machine, commonly referred to as the gooseneck. These lights help to illuminate the front of the blade's work area and should be kept clean, as they often collect dirt and grime thrown up by the front steering tires. Below the gooseneck and atop the drawbar are numerous hydraulic lines running towards the front of the machine. These lines can become damaged by the gate being stowed incorrectly. You can see here where the gate has made repeated contact with the drawbar as well as the hoses. It is extremely important to check these hoses as they control your steering as well as your wheel lean. Looking forward, you will find that the drawbar narrows down before eventually leading into a ball joint. This ball joint is how the drawbar connects to the frame and requires a generous amount of grease. Straddling the front of the frame, we find the steering linkage. This area contains cylinders for both steering and wheel lean. Additionally, you'll find this area to include a multitude of grease points that all require lubrication. This is also a good time to survey your front steering tires. This damage was likely caused by a gate poking into the tire. Above the front tires are your headlights. Ensure they're clean and keep an eye out for cracks in the lenses or loose wires coming into the housing. At the very front of the grader is a series of hooks that will hold your tire chains. These chains should be inspected periodically to ensure they are fit for duty should the situation arise. Along with the tire chains, you'll have a set of chain pliers. These can be used to repair or remove broken crosslinks while out in the field. When using tire chains, it is recommended to use rubber tension straps. These straps may be hanging on the front with the chains or located in a metal toolbox on top of the drawbar. Inside, you should also find extra gate pins should you lose one while working. Behind the toolbox is the circle drive. The circle drive provides the hydraulic power necessary to rotate the turntable. In addition to containing many hydraulic lines, this area often collects a lot of snow and ice. Thus, it should be cleaned off regularly to inspect for leaks. Above the circle drive, you'll find another front work light. Behind that are your hydraulic accumulators. These serve an important purpose in that they allow the machine to give and release pressure should the moldboard hit a solid object. The accumulators help to protect the operator as well as the machine, so they too should be inspected for leaks. Now that you can see the front of the moldboard, take this opportunity to inspect the front of the cutting edge. This angle allows you to see if they are wearing evenly or if there are any bolts that are improperly seated. Moving back towards the cab, we have our diesel fill point, as well as another ladder. Behind the ladder is another work light. Below the work light is the fill point for our DEF, or diesel exhaust fluid. Some older models may not have an exhaust treatment system and may not require DEF. Lastly, there is a windshield washer fluid fill point located at the rear left corner of the cab. Finally, the last thing to do is to inspect the left side of the cab's lights, ladder, windows, and wipers. Note that any damage found during your walk-around should be documented and reported to your supervisor. Now that we've completed a thorough 360 walk-around for the outside of the machine, we're ready to climb in and move on to the interior. Before entering the grader, open the door fully so that it locks into the open position. Next, it's imperative that you keep 3 points of contact with the machine at all times. Use the ladder as well as the handrails, but never use the moldboard as a step. After safely climbing into the cab, you'll need to close the door. To unlatch it from the fully open position, lift up on these levers mounted next to the interior handrails. Conversely, if the door is closed, you can open it by pulling up on the levers mounted to the inside of the door. Once inside, we'll focus on 3 main points of interest. First, the operator station. Second, the switch panel. And third, the center console. These 3 areas will provide the controls necessary to operate the machine, but it will be up to us as operators to understand them. To help with this, we'll start by exploring the operator station, along with its various adjustments. First, and most importantly, is our seatbelt. Because of the M-Series grader's high visibility design, there is no physical barrier to prevent the operator from being ejected should a serious accident occur. Therefore, the seatbelt is the only reliable way to ensure that the operator stays within the seat at all times. Additionally, the seat contains a safety sensor that will detect when the operator has left the seat. While out of the seat sensor will not allow the machine's hydraulics or transmission to engage, preventing accidental or unwanted movement. While active, an amber light will illuminate on the center console. On the front of the seating column, you'll find several adjustments available, with the first being a small plunger switch. This is our seat's air ride control, and it will regulate the height of the seat as well as the pressure within it. Pulling the plunger out will release the air, decreasing the pressure while also lowering the seat. Conversely, pushing the plunger in will charge it with air, increasing the pressure while raising the seat. Next to the air ride control is a small indicator with white, green, and red bars. While sitting in the seat and adjusting its air ride control, it is recommended that you align the center white bar within the green area for a balanced suspension. Nearby, on the corner of the seating column, is a small lever. This is the seat's suspension dampener, and it provides additional resistance to the vertical movement of the seat, changing the amount of bounce or springiness within the seat. This lever has multiple positions and can be set to your liking. Moving up, you'll find a pair of wide paddles. The first paddle is the slide adjustment, and when pulled, will allow the entire seat to slide forward or back. The second paddle is the backrest angle adjustment and will allow the backrest to tilt forward or back. Some models may also be equipped with a toggle switch that enables the heated seat. Behind the backrest is a knob that controls the seat's lumbar adjustment. This knob can be rotated to change the lower back support within the backrest. Similar to the seat, the armrests have several adjustments that will aid in operator comfort. The first and largest adjustment will be the switches located on the rear, outside corner of each armrest. These control the armrest's vertical adjustment and will move the entire armrest, along with the joystick, up or down. Our next adjustment comes from a set of elongated metal loops found on the forward outside corner of each armrest. These are your armrest slide levers, and when pulled up will allow the entire armrest, along with the joystick, to slide forward or back. Our third adjustment is a set of large rubber knobs located on the outside of each armrest. These knobs control the 4 armrests and can be turned counterclockwise to loosen, allowing the adjustment of the 4 armrests above. Once loose, the 4 armrests can be moved vertically as well as tilted forward or back. Between the 4 armrests and the joysticks, you'll find a small wrist rest. On the inside of each wrist rest is a small round knob that, when pulled out, allows the wrist rest to be moved up or down. The final adjustment relates to the auxiliary hydraulic pod located next to the right joystick. Below the pod, you will find a T-bolt that, when loosened, allows the pod to be adjusted vertically as well as rotationally. Take some time to try all of the adjustments to find a safe, comfortable position that works for you. Once comfortable, we'll move on to the controls, starting with the left joystick. The left joystick controls most of the primary functions necessary to transport the machine. Leaning the joystick left or right will steer the machine. Twisting the joystick will articulate the machine. And pushing or pulling the joystick will move the left side of the moldboard up or down. Pushing the left joystick completely forward past the detent will put the left side of the moldboard into float, causing it to automatically lower itself to the ground. When in float, a green light will illuminate on the center console. On top of the left joystick are several buttons that control additional functions. The 2 black buttons will lean the front wheels left or right. Between them are two yellow buttons that control the transmission's gear selection, allowing you to shift up or down. On the edge of the joystick is an additional yellow button that will recenter the machine after articulating. Lastly, there is a 3-position trigger on the underside of the joystick. This trigger controls your transmission, allowing you to select forward, neutral, or reverse. Transitioning to the right joystick, you'll find that its functions relate more to the implement. Leaning the joystick left or right will slide the moldboard out to either side. Twisting the joystick will rotate the circle, and pushing or pulling the joystick will move the right side of the moldboard up or down. Pushing the right joystick completely forward past the detent will put the right side of the moldboard into float, causing it to automatically lower itself to the ground. When in float, a green light will illuminate on the center console. On top of the right joystick is a thumb hat switch that will provide additional functions. Rolling the thumb switch up or down will pitch the moldboard forward or back, while rolling the thumb switch to either side will shift the drawbar left or right. On the underside of the right joystick is a yellow button that, when depressed, will toggle the grader's differential lock. The differential lock forces both sides of the grader's wheels to rotate in unison, helpful in slippery conditions or when moving heavy material. However, the differential lock should not be used at high speeds, when making hard turns, or when the wheels are already slipping. When the differential lock is engaged, a green light will illuminate on the center console. Above the differential lock is a trigger switch that does not function unless the throttle lock mode is enabled. More on that later. As mentioned previously, there is an auxiliary hydraulic pod located next to the right joystick. This pod has multiple programmable switches, the leftmost of which controls the moldboard's gate. Note that some machines may have additional functions programmed to the other switches, such as for a nose plow or rear ripper. Because of the gate control, you'll want to position the auxiliary hydraulic pod so that it may be controlled with your right pinky finger, whilst keeping your right hand on the joystick. Some machines may have an additional programmable hydraulic switch that can be located to the right of the operator station. Finally, there are two more controls located within the right armrest. Between the wrist and forearm rests is a switch that controls the grader's turn signal indicator lights. Next to that is a yellow button for the horn. Now that you understand the control scheme, we'll take a look at our switch panel, which is located on the column to the right of the operator station. The exact location of each switch may vary, so we will focus on the symbols as well as their functions. Be aware that some functions may not be available despite having a physical switch. First is the switch for throttle lock mode. Throttle lock mode can be enabled in either auto or manual, and it provides the operator with the ability to precisely regulate the engine's RPM by setting a constant engine speed. To the right of the throttle lock mode is the throttle set switch. This will set the engine RPM if throttle lock mode has been enabled. This switch can also be used to increase the RPM once the throttle is set. Additionally, we spoke earlier about a trigger switch on the underside of the right joystick that was related to the throttle lock mode. This trigger switch will decrease the set engine RPM when throttle lock mode is enabled. When throttle lock mode is enabled, a green light will illuminate on the center console. This switch will activate the grader's hazard lights. To the right is the switch for automatic transmission mode. When enabled, it allows the machine's computer to handle the transmission's gear shifting. The next switch is for a set of cab lights that will illuminate the right side exterior of the machine, useful for monitoring your snow berm placement as it exits the gate. Next to that is a switch for automatic differential lock. This switch will allow the machine's computer to determine when to engage the differential lock. Some machines may also have an extra switch here that enables automatic articulation. This will add articulation when steering the front tires with the left joystick and can be enabled in either forward only or forward plus reverse. Next, we find a pair of switches for the work lights. These two switches control several sets of work lights mounted around the machine. These switches have two settings, forward only, as well as forward plus reverse. The third switch will have a red safety toggle and is for the hydraulic lockout. When activated, the hydraulic lockout will disable the controls, preventing the machine from moving. When enabled, the hydraulic lockout will also illuminate an amber light on the center console. Moving up, we find another pair of light switches. The first switch has two settings, front headlights or marker lights. The second switch will toggle the high or low beams within the front headlights. When the high beams are activated, a blue light will illuminate on the center console. The third switch controls the hydraulic accumulators. As mentioned previously, the hydraulic accumulators are what allow the machine to give should the moldboard strike a solid object. This feature serves to protect the operator as well as the machine and should always be enabled while performing snow removal operations. Moving up, we have a switch that controls our strobe lights, both for the top of the cab as well as for the rear of the machine. Next to it is a switch for the heated mirrors. Nearing the top of the switch panel is a switch that controls the machine's exhaust treatment system, also known as regen. Holding the switch down will disable the active regen, while holding the switch up will allow it. Next is a switch for the cab fan, which can be located to the left of the operator station. This switch can be activated in either high or low. At the very top of the panel is a switch with a red safety toggle. This is the switch for the saddle's hydraulic pin, and when enabled, will retract the hydraulic pin from the saddle, freeing the drawbar, allowing the operator to change the saddle position. Additionally, enabling the saddle pin switch will illuminate an amber light on the center console. Above the switch panel are your windshield wiper controls. These four knobs control the wipers on the front, rear, and both doors. Each knob can be rotated to change wiper speed or pushed inward to dispense washer fluid. There are two more wipers located on the left and right side windows. These wipers are controlled by switches mounted to the wiper motor housings. These switches have two settings, on and wash. To the right of the window wiper controls are the cab's climate controls. The cab has several styles of vents, and you may want to take a moment to locate and familiarize yourself. Adjust them accordingly to help reduce condensation within the cab. Below the climate controls is an AM/FM radio, many of which have Bluetooth connectivity. Below that is the municipal street maintenance radio. The large knob on the left controls the volume while also serving as the power switch. The small knob on the right will change the active channel. On the right rear column will be a fire extinguisher. Ensure that the fire extinguisher is secured with the safety pin in place and that its inspection tag is current. On the left rear column is an emergency escape tool. In case of an emergency, the metal end of the tool can be used to break open the windows, while the bottom end contains a small razor blade that can be used to cut off the seat belt. Behind the seat, in the upper rear corners of the cab, will be two fresh air vents that can be opened or closed. Between them, some machines may also have a retractable sun visor mounted on the rear window. On the floor to the right of the operator station, there should be a small basic first aid kit. Looking forward, at the top of the cab will be a screen for the machine's rear backup camera. Below the backup camera is a rear view mirror. Lastly, we come to our center console. The center console houses a display screen, multiple gauges, as well as several buttons necessary to navigate the machine's computer. Towards the bottom of the center console, we have two switches.
The first is the switch for conducting a secondary steering test. More on that later. The other switch has a safety toggle and it controls the machine's parking brake. When the parking brake is set, a red light will illuminate on the center console. Below those two switches is the machine's ignition. At the very bottom of the center console are 3 pedals. On the right is the accelerator pedal, in the middle is the brake pedal, and on the left is the inching pedal. While the inching pedal is not a clutch, like a clutch, it can be used to move the machine in small increments. With the machine in gear, depressing the inching pedal will disengage the transmission. Conversely, releasing the inching pedal will engage the transmission, causing the machine to move. Now that we've identified everything inside the cab, it's time to move on and take a look at the startup procedure.
Now that we're ready to start up the machine, fasten your seatbelt and begin by turning the key to the on position. Once on, the center console will perform a few tests, with one of them being an audible alarm. Next, the gauges will cycle. The gauges represent engine coolant temperature, hydraulic oil temperature, engine RPM, fuel level, def level, and articulation angle. Once the gauges finish cycling, we are ready to start the machine. Note, the grader will not start unless it is in neutral with the parking brake set. Start the machine by turning the ignition past the on position. Once the engine is started, some additional lights will illuminate as the center console completes its final tests. Often, you will be met with this screen stating that the steering is not aligned. To correct this, simply lean the left joystick so as to align it with the front wheels. They will synchronize and the wheels will begin to move and respond to the joystick's input. Once the steering is aligned, the main screen will activate, displaying multiple pieces of information. This will include direction, gear selection, speed, and engine hours. You will be able to access the computer menus by using the buttons on the right side of the center console. From the top, we have directional pad to navigate, OK button to select, return button to go back, user profile button, info button, and a backlight display button. From the main menu, there are a couple of important settings that you should be aware of. Within the transmission settings, you're able to select the initial forward gear as well as the initial reverse gear. These will determine the starting gear used when the transmission is engaged. Within the implement settings, you're able to change the modulation configuration. This setting will change the joystick sensitivity in relation to the moldboard's lift cylinders. Another area of interest will be the service menu, where you can see all active service fault codes. If an active code is present, a wrench icon will be displayed on the upper portion of the main screen. Earlier we mentioned a switch for a secondary steering test. In the case of an emergency that results in steering loss, the grader will automatically activate a secondary steering system. This system will allow the operator to safely guide the machine out of the road. Although this system enables automatically, it is important to test it periodically to ensure that it's functioning. To conduct a secondary steering test, activate this switch so that an amber light illuminates on the center console. Once lit, use the left joystick to steer the front wheels both left and right. After about 10 seconds, the amber light will deactivate, ending the secondary steering test. Moving on, look up to ensure that the backup camera is active and that the rear view mirror is properly adjusted. Next, confirm that your side view mirrors are clean and that they are angled correctly. Once satisfied with the visibility, activate all of the light switches located on the switch panel. You're now ready to move the machine. Start by lifting the blade off the ground. Next, place your foot on the brake pedal and disable the parking brake switch. Finally, put the machine in reverse and slowly back out of the parking space. Note that the inching pedal can be used to help gently creep backwards. Once outside, use the joysticks to test all of the hydraulic functions while keeping an eye for leaks. While testing the controls, you should also be monitoring the amount of play found within the ball and cup joints, as well as the circle shims. Finally, step outside to do a final 360 walk around of the machine. Ensure that all the lights are functioning and that no leaks are present. If everything is functioning correctly, you're ready to go to work. At the end of your shift, you'll need to park the grader back into its correct parking spot. To do this, start by pitching the moldboard into a plumb, upright position. Then lower the gate and slide the moldboard all the way to the left. Next, center the circle below the gooseneck and rotate the moldboard counterclockwise so that the gate tucks in behind the front right tire. Pull into the parking space before putting the transmission in neutral and setting the parking brake. Lower both sides of the moldboard to the ground and put each side in float. Once the implement is grounded, you may need to open the gate slightly so as to prevent additional strain on the gate's frame. With the machine parked in neutral and the implement grounded, you are now ready to turn off the ignition. Note that some graders will not shut down immediately as they need extra time to cool down. After shutdown, some machines will need to purge their exhaust systems, which will result in an additional message being displayed on the center console. Turn off all of the lights and take a few moments to survey the cab. Pick up your belongings, remove any trash, and sweep out the floor. When finished, close both doors. Once out of the machine, make sure to do one last 360 walk around to look for any leaks or damage that may have occurred during your shift. If there are excessive amounts of snow and ice built up on the machine, take a few moments to shovel it off. Next, open the rear left panel and hang the fuel flag. Inside the rear left panel, next to the battery disconnect, you may find an amber light. Do not turn off the battery disconnect if the amber light is illuminated. The amber light indicates that the machine needs more time to purge the exhaust treatment system. Once the amber light deactivates, you are free to turn off the master switch and walk away.